Hello and Namaste. Welcome back to Alpa Active Learning. So children, I hope you are enjoying my videos. Today, Standard 8 Science. Topic Inside the Atom Part 1. Now children, every day in your school you might have played with the chalk. You have seen the pieces of chalk. You have also seen the chalk dust falling from the blackboard. Now, the chalk and the chalk dust, they are made up of the same material, but the chalk dust is very fine. Similarly, you have seen sawdust. It is nothing but a small particle, small part of wood, the wood from which we make furnitures. Gold dust, a very small part of gold, and the gold is used to make ornaments. We inflate the balloon and we know that air is inside. So whether it is chalk dust, gold dust or sawdust, all these parts are visible parts, right, of the matter of what it is made up of. So actually, can we further divide this? Is it possible that this sawdust or chalk dust or any minute particles, can it be further divided? Matter is made up of molecules. But what are molecules are made up of? They are made up of atoms. We all know that the matter exists in gaseous form, liquid form and solid form. And all these are nothing but molecules. In the gases, they are very much scattered. Whereas in liquid, as compared to gases in the solid, there is some space between them. But here in solid, the molecules are in a very closed contact. So, these molecules are formed by the chemical combination of the smallest part known as atom. Look at this. You have heard about oxygen, water, salt and sugar. So this is the way new chemical combinations happens, right? So we say that molecules are formed by the chemical combination of atoms. Let's see. Water, H2O. Now if you think what is water made up of, we all know. It is a combination of hydrogen and oxygen. So it is a molecule, and yes, we are using hydrogen and oxygen. But what is oxygen gas? It is entirely made up of oxygen itself. So it's a molecule but single type. Helium, it is an atom and again a single atom. Hydrogen, hydrogen gas, yes, it is also a molecule, and here also a single type of atom is found. But if we see ammonia, here N and H, N means nitrogen, H is hydrogen. So it's a molecule. There are two different types of atoms are found. So first of all, let's understand what is an atom. Acharya Kanak, he is known as the father of atomic theory. He is an Indian philosopher. In 16th century, he proposed that the matter is made up of Parmanu. In Sanskrit, Parmanu means indestructible, indivisible. So this is the smallest part which cannot be further divided. The same concept was given by Greek philosopher Democritus. According to him, the smallest particle of matter was named as atomos, which is not further divided. So, now this was a proposed, but in a modern concept, the atomic theory is evolved, and because of this atomic structure of theory, children, today the entire entire field of chemistry has evolved. So it started from John Dalton in 1803. Then Sir J.J. Thomson has given his valuable contribution. Afterward, Ernest Rutherford. So it took nearly more than 100 years to arrive on a concrete structure. Let's understand how it started. So Dalton's atomic theory was given by British scientist John Dalton in 1803. He also believed that matter is made up of small particles. But according to him, atom is a hard, solid sphere with no internal structure. Now children, you take a bundi ladu. And we know that to make this laddu, we need number of minute small bundis which are kept together. So even if you break this, you can find the smallest bundi inside it. But Dalton says that if you even cut it, you will not get any internal structure. So according to him, atom is solid from inside. And the mass is distributed uniformly in an atom. Right? So this was his first proposal. Later on, now this theory has certain demerits. Demerits means limitations. It does not propose about positive and negative charges. It does not explain about many properties. But however, this postulate becomes a fundamental postulate. Sir J.J. Thomson in 1904 proposed one more model. The model is known as raisin pudding model. Now, according to him, like a raisin here, the positive charge is distributed throughout the atom and the negatively charged electrons are embedded in it. So he says that an atom is a sphere which has positive charge and negative charge. Embedded means it is firmly present inside the nucleus. So it is Thomson who comes with the concept of positive and the negative. If you see Johnson's model, let us consider that an atom has charges. Here I have taken 5 positive charges, and according to him there are negative charges are there. So I wrote -5 for negative charges. Now we all know +5 -5 is 0. That means even though the charges are present in an atom is electrically neutral, and this is in today's also it is accepted this theorem. Then come Ernest Rutherford, who has explained this very more successfully with in depth in 1911. For this he has done an experiment known as scattering experiment of gold foil. Now let us understand what is this experiment is. For this, as you can see here, he took the radioactive source which has alpha particles. Now alpha particles are positively charged particles. Now these particles are bombarded, are made to fall on gold foil. A very thin sheet of gold is kept and this particle has to pass through it. Again you can see one detector or a screen is covered through this gold foil. So when the radioactive source has emitted the alpha particles, as you can see here, 3 things observed. Some rays directly passes through, some are deflected with short angle, some are deflected with a larger angle, and very few one you can see here it returned, right? But that the number of that thing is very small after, right? So now what it means, again observe this thing, observe the gold foil, how it passing through this, see the position of this alpha particles after deflection. Okay, keep this in the mind. Let's now, our first observation says that most of the alpha particles went through the foil. Now here if you throw a ball, if there is a hollow space, the ball will cross the fence. That means there exists some empty space in the atom of the gold foil. Now we have also seen that small number of alpha particles get deflected some through the original path in a small angle, whereas some are deflected through the larger angle. Now let's throw one more ball. Now here this ball is obstructed. It is stopped. Why? Because you can see that there is something, the wood part is there. That means the ball will return. So same way here alpha particles get deflected. Now we know alpha particles are positively charged. So here there must be a repulsion. Now how repulsion takes place? Positive and positive charge, like charge is repelled. Alpha particles are positive. That means there must exist some positively charged particle in an atom. So two important conclusions we have done from the Rutherford's model is that there is an empty space inside the atom and there are positively charged particles also present in the center of the atom. However, the mass may be very small. So with this, he says that there is a positively charged nucleus at the center of an atom. Entire mass of the atom is concentrated in the nucleus. You can see these revolving electrons. They are revolving around the nucleus and it is known as an orbit. And between the nucleus and an orbit, there is an empty space. The theory also has a shortcoming. According to Rutherford, he says that atom is unstable. Now, when an electrically charged body is revolving in a circular orbit, its energy decreases as per the physics. But in Rutherford models, they say that the atom is very unstable. But in reality, all the atoms except radioactive atom are stable. So this thing is Rutherford failed to explain that why these atoms are unstable. However, Niels Bohr in 1913 has given a very stable orbit atomic model. According to him, the electrons revolving around the atomic lie in the concentric circular orbit at a certain distance from the nucleus. So electrons revolves in an orbit. Second, energy of an electron is constant while it is in a particular orbit. That means if electron is revolving in the same orbit, the energy will remain the same. But however, if an electron jumps from one orbit to another orbit, it absorbs energy, and if it jumps from an outer orbit to the inner orbit, it will emit the energy. So only when the electron is changing its orbit, there is absorption or emission of energy takes place, which is equal to the difference between the energy of that orbit. So children, after this, a new branch of quantum mechanics in which they have studied very deeply about atomic structure. So Bohr said that after the nucleus, an atom has 4 shells here: K shell, L shell, M shell and N shell. So he proposed that there are 4 orbits and he named them as K, L, M and N. Okay, so what is an atomic structure? So every atom has a nucleus. A nucleus has positive proton and neutral neutron. A nucleus having positive proton, neutral neutrons, and it has electrons which are negatively charged and they are revolving around the nucleus in an orbit. So this is a atomic structure of every atom successfully derived. Every atom has 3 fundamental particles: proton, electron, neutron. Protons positively charged, electron negatively charged, whereas neutron are neutral. Proton has symbol P, electron has E with minus sign, and neutron has symbol N. Now, proton and the neutron are subatomic particles, whereas electron revolve around the nucleus. Each proton carries a positive charge of 1 electron, that is 1.6 into 10 raised to minus 19 coulomb. Whereas the charge of an electron is 1800 times less than that of the hydrogen atom. One thing you should remember, children, that number of proton and number of electron are same. So let's take an example of hydrogen. Hydrogen symbol is H. You can see here it is 1 proton and 1 electron. Hydrogen is the only element, you can say, where there is no neutron. So in the nucleus you can see only proton. On the basis of the number of proton and electron, scientist also has given the symbol to represent every element with its atom. So every element has atomic number and atomic mass number. We represent atomic number by letter Z and mass number with letter A. It is the number of proton, and number of proton is equal to number of electron. So total number of proton in the nucleus of an atom is atomic number, whereas total number of proton and neutron in an atom is atomic mass number A. So I can say that Z is equal to number of proton or number of electron, and A is equal to proton plus neutron. In a sum, I can say I can represent the symbolic form of any element as AXZ, A to Z, where X is the name of an element, A is atomic mass number, and Z is atomic number. This is an identification, recognition, symbol, whatever you say. But if you know A and Z, children, all the physical and the chemical property of any element. Now, A is atomic mass number, Z is atomic number. So with Z we know number of proton and number of electron. Once we know this thing, we can find out number of neutron by subtracting A minus Z. Okay. Now let's take example. H stands for hydrogen, B for boron, O for oxygen, Cl for chlorine, and U for uranium. Now, hydrogen has 1, atomic mass number 1, atomic number 1. So here proton and electron are 1. But for boron, atomic number 5, electrons 5. That means his place is at number 5. His roll number is 5 because number of electrons are 5. So protons are 5. Now 11 minus 5 is 6. So neutrons are 6. For oxygen, atomic number 8. So roll number is 8. Number of electron 8. Proton 8. And here neutron also 8. Now for sodium, Na means sodium. Here it is atomic number 11. So electrons 11, protons 11. Naturally 23 minus 11 is 12. So neutrons are 12. For chlorine, atomic number 17, mass number 35. So here 17 proton, 17 electron. 35 minus 17 is 18. 18 neutron. Now uranium, very important mineral. So here 238, 92. Atomic number is 92. So number of electrons are 92. That of protons are 92. And if you subtract this, whatever the number you will get, that is your number of neutron. So children, you must know at least atomic number, the symbol of first 30 elements. Thank you so much. Do like video, comment, and yes, stay tuned to part 2.